Hi, in this video we are going to learn a technique called completing the square. Before we learn that technique though, we do need to know what constitutes a perfect square. So I have three examples here for us to look at. Notice that each one of them can each be written as some quantity squared, right? So if we're looking at a constant, perhaps that number is an integer squared. If we're looking at something with a variable that has an exponent, can we rewrite that as something squared? And in this case, we can, right? 4 is an even number, so we could rewrite that as x squared squared. We could also have a combination of things. We could have a coefficient, right, connected with this variable here. We could rewrite 9x squared as the quantity 3x squared, right? And that actually doesn't just stop there. We also can have multiple terms in that quantity. So this example of x squared plus 2x plus 1, right? If I were to factor that into x plus 1, that's the same thing as x plus 1 squared, right? That's a quantity that's been squared. And we can see where that square is coming from, right? Obviously, the x times x is a square, right? X squared is a square, and 1 is a square. But when we rearrange things, right, we have these two other rectangles put in here. When we rearrange them, they do create this square. So not everything is a perfect square, right? So x squared plus 4x, I can't factor that into factors that are identical, right? This would factor into x times x plus 4. That's a rectangle, right? Even though this portion of it is a square, the overall shape is not a square. All right, so why do we want to have a perfect square? We will get up to that. I would like us to learn this technique first, though. So since x squared plus 4x isn't a square, right? We did see an example of something that was a square, right? It started with having an x here and an x here, had this x squared here. Is there something that we can add on to this expression, maybe a constant, right, so that it would create a perfect square? Okay, so let's think about that. What would have to go into these two rectangles for this entire shape, right, the dark blue line, to be a square? Well, a square has equal sides. So if this rectangle has half of the 4x, right, that would be 2x, then the other half would get the 2x, meaning that this side here would be 2, as would this side, right? And that means I'm keeping this length consistent with this one, and I'm creating a square. It's not done yet, though, right? All I've done is split up my 4x into these two rectangles. I still need this little mini square down here in order to complete this square. So what would the area of that square be? Its side lengths are 2 and 2, so that would be a 4. So that is the value that completes the square, right? Hence the term completes the square. So let's think about that. We took the 4x, we split it in half, right, to get these 2x's. We figured out what these sides would be. So in other words, we're really just focusing on that 4. We're taking half that value, and then this is the square of that value. So we could do that again, right? Let's complete the square for this expression. What number would we need to add here to complete the square for x squared minus 10x? So let's go with our strategy again. Negative 10x, we can split that into a negative 5x on each of those rectangles. These sides would be negative 5. And it doesn't really matter that these are both negative, right? Because when I multiply those two negatives, we come back to a positive again. So that seems to be that we take half of this value and we square it, right? That's that missing component if we wanted something to be a square. What about an odd number? What would we have to do in that situation? Well, we're still going to cut it in half. It's just that we're going to have a fractional component here, right? So half of 7, I'm just going to write that as 7 halves, right? We're going to put each half in one of these rectangles. That means that this length here is 7 halves, And to fill in this box, that's the area, right, of a square that has a length of 7/2 and another length of 7/2. So I'm multiplying 7/2 with itself, and I get 49/4. That would be the value that completes the square. So we're going to ask you at some point to just find this number. What number would we need to complete the square? We're going to go further with it, but that's really the first step. Okay. One more thing that we want to consider is a variable, right? It's a process, right? We're doing the same things over and over again. So even if this was a variable, we still are going to follow that process. And that process was to take half of that value, right? So b/2. That's our length. And then we square that length to find the area of this of this square, right? So this would get us b²/4. So now we've seen this. Let me go back here. I'm going to go backwards. We have seen this with a positive number, an even number. We've seen it with a negative even number. We've seen it with a positive odd. We could do a negative odd if we wanted to. And we've seen it with a variable, right? So we could do this with anything. It is very important that we don't confuse completing the square as a simplifying step, okay? We are not simplifying things. The expression x² + 4x is different from the expression if we add on that constant that completes the square, right? So if I complete the square here, half of 4 is 2, square 2, we get 4, right? Those are not equivalent expressions. This expression is now a square. This one is not, right? So those are not the same thing. So it's important to understand that when we add to an expression, it creates a completely different expression. There hasn't been any balance to occur to say that these two things are equal to each other. They are absolutely not equal to each other. This is 4 more than this one, right? So when we complete the square, we do have to balance what we do in that process, okay? So when we have an equation, now there are two sides that we can balance that out with, right? An equal sign separates two sides, and we are to assume that those two things have the same value. This is in balance right now. So if I take that same exact expression, right, the x² + 4x, and I complete the square by adding a 4, this side is no longer, right, equal to this side here. I have to do something to make them equal. I have to balance. So there's two ways that we could do that. Here's one way. If I added 4 to the left, all I have to do is add 4 to the right, and I have maintained that balance, right? This left side can now be rewritten as a perfect square. The right side can be simplified, right? When we add a value to each side of the equation, right, the same value, we have not upset the balance. There's one other way to balance. I'm going to go back to the beginning here, right? We have that same expression, x² + 4x = 6. If I add the 4 to complete the square, I don't have to add 4 to the other side to balance. The other option is to subtract 4 from the exact same side, right? Now I can complete my square, right, with this trinomial here, rewrite that as a square, and I'm just going to have this extra -4 on this left side, right? Either way, we have not upset the balance. It doesn't matter which way you do, right? But you have to do one of these ways in order to maintain that balance. Okay, so back to what I was trying to start our conversation about before, but now we're ready to talk about it. Why do I want to complete a square? Why do I want to work with perfect squares? The answer is vertex form. This is what vertex form is, right? When I am graphing and solving quadratics, I like things to be in vertex form, meaning I like there to be a quantity squared, and I'm okay if it's being multiplied by something, and I'm okay if we're adding or subtracting something at the back of it, okay? That's what vertex form looks like. I like to graph it because we already know how to graph it. We learned all those translations already. I also like it to be in this form because it's very easy to solve for x. I can do inverse operations to undo this, undo this, undo this, and undo this, and then I get x by itself and I can solve an equation, right? So this vertex form has to have that square in it. So we're going to see some questions that are setting us up to put things in vertex form, okay? There's one other thing we have to talk about, and that's what happens when this a value, when I say a, that's the number in front of the x squared there. That's the coefficient of the quadratic term. When that a value is greater than 1, I have to adjust some things, okay? There are two ways of doing this. We have to know both, and for good reason. I might not mention it in this video, but we will definitely talk about it in class, why we should know both. So here's the first method. The first step is to factor out that a value, this 2. I'm only going to factor it out from the quadratic and the linear term though. Okay, so in this case, I'm going to factor a 2 out of those two terms. Done. Now I have this quadratic inside the parentheses here that has a 1, right, an invisible 1 right here in front of the x squared. Now I can work with that the same way we were doing the other expressions up until this point, right? So I can complete the square with this stuff right here. I created a little space, right? I want to add something in here. What am I going to add? Well, I go over here to my negative 10. I take half of that value, that would be negative 5, and I square it. That's 25. Perfect. I don't just add a 25 in here, though. I have to balance. I'm going to balance by adding that same value over here, but not so fast. I added a 25 to the left side, but look what happens to that 25. It's inside of these parentheses, and that set of parentheses is getting multiplied by 2. So I didn't just add a 25, I added a 2 times 25. So make sure we're balancing with the correct amount, okay? Next, we're just going to rewrite that as a perfect square and clean up anything that we need to clean up, right? All right, so I still have that 2 in front. My parentheses is now a perfect square. That perfect square is x minus 5 squared. And cleaning up the right, we get to the 57, okay? So we completed the square and we kept our balance. The other method, this question was taken right from Delta. It's asking, what is the intermediate step in the form x plus a quantity squared equals b as a result of completing the square for the following equation? It's saying, take that, complete the square, fill in what it turns into when it looks like this, right? Here's our second method. You might like this method better, but you still need to know both, right? I'm not telling you why right now, but you still need to know both. First step, you want to gather your quadratics and your linears on the same side so it looks similar to the one we just did. So I'm going to move that 36x over. I also like the idea of moving this constant over to the right because obviously this is going to equal something. I might as well just get it out of the way. Okay, so I'm just reorganizing things. The next step. That 6 is the problem. In method 1, I would have factored out this 6. In method 2, I'm going to divide both sides of the equation by 6. It turns into that. Right? It seems like a nicer way to us because we're making numbers smaller. I agree. It is a nice way. If I can do this, it is a nice way of doing it. Now we have an x squared, right? A 1 in front of that. I can complete the square. So if I complete the square on the left here, the magic number that helps me do that is 9. If I add 9 to the left, I have to balance by adding 9 to the right. And lastly, I clean up by rewriting this as a perfect square right? This is going to be x minus 3, quantity squared. Oops, that should be a minus. Hold on, that should be a minus right there. There we go. And this side simplifies to a 98. Okay. One more thing. I know a lot of you have been asking for ways to prepare for our apt at the end of the unit. Why don't we try it right now? We're probably not ready for this, but it's a good idea to see where this can go, right? And I think that's what we struggle with a lot. So if you want to try this now, that would be fine. If you want to save it for later, that's fine too. But this is a huge jump, right? In terms of difficulty, we haven't done one that looks like this before, right? I thought it would be a good idea to throw that at you and see what you can do with it. Good luck.